Hello everyone, welcome back to my channel. In today's video, I will explore how to use GitHub Codespace to work with Terraform for Azure Cloud. All I will do without the need for a physical installing Visual Studio Code. This is a powerful cloud-based development environment that simplifies your Azure infrastructure as a code journey. If you are managing your infrastructure as a code, this is an essential skill to have. So let's dive right in without further wasting time. So step one, set up your GitHub repository. So first ensure you have one GitHub repository ready with your Terraform code. Create a new one or use an existing repository if you have it. So the step two is access GitHub Codespace. So from the code, there will be a code space. So hit the code space create button. So it will take time. So this will open a cloud-based development environment for your project. So now this integrated terminal also open for the bash environment. And so basically this is the same thing what we have clone in your git bash environment using git clone with your specified repository URL. So this action will fetch your Terraform code into your code space, this code space environment. Okay. So but what happened? So we'll run the Terraform init command. So uh, this is an comparatively a big project. So we'll choose the backend environment. Backend means that the Terraform state file will store in the backend storage container. Okay, so we'll use this cd backend. Before going to proceed, we need to check if the Terraform command is voila, the Terraform command not found. Okay, we'll check the Azure CLI command also not found. So we'll install this two binary in the. How can I do this? You just go to the search, then greater than symbol, then dev container, add this dev container configuration file with modify your active configuration. Just type here the Terraform binary. We will look for Terraform TL in it. Okay, this one, and the Azure CLI. Okay, this one. We need this two binary to work for. Set it as keyword default. Okay. So thus it add the two binaries in the JSON format, but it will not install as a container. Okay, we'll check. Command not found. Okay. So how can I install it? We can install it by just saying greater than symbol rebuild container. So all this JSON format, whatever we have added in the binary section, will install it on the register. We'll wait for this. For an overview, I will tell what this code space. The timing it's set up. I will tell you what about the code space functionality and overview. Okay, so the code space type is two types. We have one 2 core 8 GB RAM and 4 core 16 GB RAM. So we can upgrade based on our requirement. Okay, and this is free for 60 hours of usage per month, and if it count, then it is 2 hours per day. It's free. Okay, and this can be opened in Visual Studio Code or in browser. Okay, open a browser. As you can see in the Azure Cloud portal.azure, we need to log in. We can see this. There is no resource group created earlier. This is by default is created network voucher for resource group. Azure Cloud portal.azure. We need to log in. We can see this. There is no resource group created earlier. This is by default is created network voucher for resource group. We'll wait for this content. So now the container is restarted with added the dev container folder where the JSON file is created. So we don't need to worry about this dev container folder. Okay. So now we'll check whether the Terraform command and uh, Azure CLI command is working fine in this container. Okay, we'll check. Okay, Terraform command is working fine, and we'll check the Azure version. Fine. So now Azure CLI and Terraform binary command is working fine. The next step is to authenticate the Azure cloud from this Terraform. uh, Terraform environment. Okay, so to authenticate, use Azure login command. It will redirect to one web page for authentication. I'm using my Hotmail account. Okay, it's going to localhost. Okay, no worries. We'll use device code. Copy this follow link and copy this code. Enter the code to my Hotmail account. Continue the Azure CLI. Okay, it's good to. So if it found any error, you can specify the tenant ID there with the tenant ID. Okay. Okay. So now I will. Now the Azure authentication is working successful, and we'll go to this backend folder. So in the backend folder, whatever we have configured is like backend folder is basically we created for storing the tf state file in uh, in a remote location. Whatever we have created infrastructure that a checkpoint will be stored in a remote location. Okay, so in this uh, file we have created basically the resource group, storage account, and the storage account containers. So basically we have added the three resources. Okay, so where the state file will be stored. So I will Terraform start the. I will initialize the Terraform init command to download all the packages and modules used in this TF file. Okay. So now initialize the Terraform file. So because this is nothing but a Terraform project, by running Terraform init command in the terminal. This will prepare your working directory to run the Terraform plan and apply. To preview the changes, whatever need to be applied for the infrastructure, use Terraform plan. It will display the change, display the action Terraform will take, and when you're ready to apply the changes, use Terraform apply. See, this will plan 3 to add. So as I told you, this will create a 3 resources as per written in the main.tf file. And if we hit the Terraform apply with an auto approve, it will not ask for a yes. So basically it will create and resources will be and the resources will be provisional according to your Terraform code. See, the TF state and storage account names, these things I have added in my storage account. In the variable section, sorry. Storage account name and this resource group location, resource group name. Okay. So apply complete. So 3 resources added. So we'll check whether it's added or not in my Azure cloud. See, the test RG resources is created with an storage account name, this thing with the container name tf state. And inside this, the state file will be stored. Okay. The state file is nothing but this state file. This is nothing but the heart of the Terraform, where all the infrastructure checkpoint, or we can say the image mirroring will be stored in this state location. So whatever we have added or changed or like destroyed anything from this TF file, it will reflect on the TF state file. So it will check for the Terraform drift detection. Whatever we have changed in the Terraform in the Azure cloud by manual, it can check using Terraform refresh command, and it will check from the state file. So we want to store this state file inside this remote area. So that's why we have created this backend. So now this part is done. Additionally, we can install this Terraform extension. Yeah, this was already installed. So this will for syntax viewing and auto type for this Terraform models and resources. Okay. Suppose we need to create one where we need to change the variable resource group name to the test to the dev environment. Okay. So this can be applied to the same Terraform plan. Okay. It will change the test RG to dev RG. Okay, and these are the modified, we can commit from this source control. I just want to commit this thing only, just loss, then commit, just add any commit, uh, change resource group. variable name, then commit sync. See, it's updated in my variable.tf file. Perfect. Now I want to destroy whatever created in my infrastructure. Okay, just use Terraform destroy. So Terraform destroy will track the changes from the state file and comparatively with the infrastructure. Okay, if it is found, then it will destroy. So in this section, whatever commit and push I have done is basically same. Like after applying the changes, commit your code with the git commit ID, git commit message, and push it to your GitHub repository using git push command. So this is the same. So while I'm tried the Terraform destroy, it will destroy this resources. Say it's three to be destroyed using an yes value. The same like collaboration with pull request. You can for collaboration create a pull request on GitHub. This will enable team members to review and merge your Terraform code changes into your main branch. So this kind of thing is we do in our collaboration teamwork. So you can do that way also for Terraform code management. Okay, the destroy is completed. Three destroy. So we have three resources provisioned, and now three resources will be is destroyed. You can see the resource group will be removed after a few seconds or refresh. See, this is refresh. Okay. So now this is the complete. There you have it, and you have successfully used GitHub Repo Codespace to work with Terraform for Azure Cloud without needing to physically install your Visual Studio Code. This cloud-based approach streamline your Azure infrastructure as a code workflow. If you found this video helpful, please give it a thumbs up and subscribe for more tech tutorials. If you have any queries or any need assistance, feel free to leave them in the comments below. Thank you for watching and see you in the next video.